So last lesson we were looking at using the null factor law in order to solve a quadratic equation that was already factorized. What we're going to be doing in today's lesson is we're actually going to be factorizing. So we're going to use the skills we learnt in our factorizing unit and apply them here. So essentially we've got a quadratic, x squared take 5x plus 6, and in order to find the two factors to factorize it, we know that we're going to need to find two numbers that multiply to give 6 and two numbers that add to give -5. So our options, first we want to find two numbers that multiply to give 6. So 3 and 2 is one option, or other factors are 6 and 1. Now we know that in order to give a positive number, we know that they're both going to have to be negative if they add up to be a negative. So we can see that it's going to be 3 and 2, and it's going to be -3 and -2 to give us +6. And then -3 plus -2 is going to add up to give us -5. So x take 3, x take 2 works to factorize this quadratic equation. Now, using Null's factor law, either this, x take 3, is equal to 0, or x take 2 is equal to 0. Okay? So, solving these equations, adding 3 to both sides, we know that x equals 3, or x equals 2, if we add 2 to both sides. So we've got a quadratic equation, we've factorized it, we've used null factor law to write it as two sets of linear equations, and then we've solved them. So what I'm going to write is a procedure. So number one, you need to, whenever you've got a quadratic, you need to rearrange it. So rearrange equation. So right hand side, so I'm going to use this a bit, RHS, that just means right hand side. So the right hand side is 0. It was already 0 in this case. So number two, our second step is to fully factorize the left hand side. So fully factorize the left hand side, LHS left hand side. Step 3, we're going to use null factor law. We're going to use null factor law to write it as two sets of equations. And then step 4, we're going to solve the resulting equations. Solve resulting linear equations. So we're going to use this procedure to solve a few example problems. So example A, so these are some examples. And this is a procedure. So example 1, we're going to have x squared equals 5x. So first step, we're going to rearrange this equation so the right hand side is 0. So to get rid of this, we're going to take 5x from both sides. If we take 5x from both sides, we're going to be left with x squared take 5x equals 0. Now, step 2, fully factorize. So what does x squared and -5x have in common? The only factor that I can see is x. So if we take out a common factor of x out the front, then and then to get x squared, we're going to do x times x to give us x squared. And then to get -5x, we're going to do x times by -5 equals 0. We're then going to use null factor law. So either x is equal to 0, or x take 5 is equal to 0. And then last step, we're going to solve these equations. So this one's already solved, so either x equals 0, and then to solve this equation, we're going to add 5 to both sides, so x equals 5. Now, I'm going to do a couple more examples. So, our next example we're going to look at is x squared plus 18 equals -9x. So step 1, rearrange it so the right hand side is 0. So we're going to do the opposite to get rid of the negative 9x. We're going to add 9x to both sides. So we're going to cancel out. We're going to be left with x squared plus 9x plus 18 equals 0. Now, second step, we're going to fully factorize. So two numbers that multiply to give us 18 and add to give 9. So two numbers would be 6 and 3. So x plus 6, x plus 3. So 6 and 3 multiply to give us 18, and 6x plus 3x add to give us 9x. So that works well. Then I'm going to use no factor law to write it out as two separate linear equations. So either x plus 6 equals 0 or x plus 3 equals 0. And then solving these two linear equations, so taking 6 from both sides, we're going to get x equals minus 6, or taking 3 from both sides, x equals negative 3. Our third example, we're going to have x squared plus 6x equals 16. So right hand side equals 0, so we're going to take 16 from both sides. I'm going to be left with x squared plus 6x, take 16 equals 0. Now we need two numbers that multiply to give us negative 16, and two numbers that add to give us 6. So 16 could be 4 and 4, or 8 and 2. Now they're not going to, 4 and 4 don't add to give 6, so 8 and 2, yeah, 8 take 2 is 6. So x plus 8, x take 2 equals 0. So that's going to work. 8 times negative 2 is negative 16, 8 take 2 is 6. So that works. Now we're going to use no factor law to write it out as two separate equations, x plus 8 equals 0, or x take 2 equals 0. So therefore x is equal to taking negative 8, or x is equal to 2. So I'm going a bit quicker on these rearrangements, but they're very straightforward once you do them a few times. So the last example I'm going to look at is this one, 5x squared, take 15x equals 50. So step 1, rearrange it so the right hand side is 0. So we're going to take 50 from both sides, and we're going to have 5x squared, take 15x, take 50 equals 0. Now, what do we know? What do we notice about all these three numbers? They have what do they have a highest common factor of? What common factor do they have? They have a common factor of 5. So if we take 5 out the front, we're going to have 5 lots of x squared, take 3 lots of x, take 10 equals 0. So we haven't fully factorized it actually, sorry. So now we've got x squared take 3x, take 10. So two numbers that multiply to give us negative 10 and add to give us negative 3. So two numbers that multiply to negative 10 are going to be 5 and 2, and then it's going to be negative 5 plus 2 to give us negative 3. So 5 lots of x plus, x take 5, x plus 2 equals 0. And now we're going to use null factor law. Now that we're fully factorized, we're going to use null factor law to write it out as two separate equations. So x take 5 equals 0, or x plus 2 equals 0. So solving these two equations, therefore x is equal to 5 to make this true. 5 take 5 equals 0. Or x is equal to negative 2.